Now students, let us take another example to understand the locate a point on a plane. I am considering a classroom. In that classroom, for example, there are 12 students. So I want to check their homework notes. Already I checked some of the students, but some of them are left. Then first I started at here. That means how can we locate this student? Here consider these are rows and these are columns. So can I consider like this? First row, third column student. That is, first I locate the students and I checked her notes. And again, here I want to check this student. Then how can I locate? I locate here again, third row, third column. So like this, we can locate a point or addressing a position with reference of with reference of the two ordinates. So one is horizontal and other is vertical. That is, one is one row and another is column. So like this, we can consider in this graph paper also. First draw an horizontal line that is generally known as X, O, X dash, and next and draw another vertical line which is exactly perpendicular, and this plane is divided 4 equivalent parts by these horizontal lines. So horizontal and vertical lines. So here horizontal is generally taken as X, O, X dash, and vertical line is Y, O, Y dash, Y, O, Y dash. So now here on right side of this O, that is generally this O is called as a origin. On right side of this origin point, we can always write positive integers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. On left side also we can write the negative. That is, I am writing a integer line on horizontal. -4, -5, -6, -7, -8, -9, -10. And here also in upward we have to take the positive values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that we can go. And again on down also -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So let us suppose I want to locate a point with reference to by taking two references. One is horizontal way and another is column way, and I would like to locate 2, 5. So for that I have to go for 2 on horizontal line. From there onwards, go vertically up to 5 units. So this is my location of point, that is 2, 5. For example, I want to take 3, 4, and again here I have to go horizontally up to 3 units. From there onwards I have to go 4 units from there. So like this we can locate the points on the graph. So these are the basic points already we learned in lower classes. So now in this class, in this 10th class, here mainly the first concept is the distance between the 2 points on a different positions. So first I am taking the 2 points on x-axis. For example, I am considering one point at this level, at this position, that is 2, 0 and this one 6, 0. So now I want to find the distance between these two. So generally by counting these units, how much you got? 1, 2, 3, 4. Otherwise, by taking directly the distance between 6, 0 and 2, 0, simply you have to write 6 minus 2. That is here generally taken as this point. First point is taken as x1, 0 and the next point is taken as x2, 0. So distance between these two generally taken as modulus of x2 minus x1. So here the distance between these two is simply 6 minus 2, that is modulus of 4, that is 4. Why this modulus? Sometimes we may get the distance between, for example, I am taking here minus 2, 0 and here I am taking one more minus 6, 0. So actually the distance between these two is 4 units only. So but while subtracting what you get, x2 minus x1. So minus 6 here x2, 0, x1, 0. If you take the x2 minus x1, then what do you get? Minus 6 minus of minus 2, then minus 6 plus 4, it is simply minus 2. But always the distance is taken as positive. So that's why you should take here what? Modulus. So this modulus represents always positive. So like this we have to do the distance between the points on the x-axis and also on y-axis. For example, I am considering this point 0, 3. Why 0, 3? Here I am locating a point on y-axis with respect to the horizontal and vertical lines. First start with 0 and go for 3 units on up. So 0, 1, 2, 3. So here the location of exact this point is with respect to horizontal line we have to take 0 with reference of horizontal line, and with reference of vertical line we have to take 3. That is, we are taking 2 references at a time. So that's why here these two are called as coordinates. So first one is called as x coordinate and second one is called as y coordinate. So in this way we have to take 0, 3 on the, and again I am taking one more point 0, 6 on this y-axis. So with respect to x-axis 0 and with respect to y-axis 6, 0, 6. So now here the distance between these two is generally taken as y2 minus y1. Here also you have to take modulus of y2 minus y1. So that is 6 minus 3. So modulus of 3, that is simply you have to write 3 units. So like this we have to find the distance between the 2 points on x-axis and y-axis by using these small formulas. So generally the general formula is what? The distance between 2 points on x-axis is simply modulus of x2 minus x1. The 2 points are what? One is x, 0 and other is x2, 0. In the same way, the distance between 2 points y1, 0 and y2, 0 on y-axis is simply y2 minus y1. So this is a one concept. And another concept is here the distance between the 2 points on a line parallel to the coordinate axis. So for example, first I am taking the 2 points on a line which is parallel to the x-axis. I am taking here 2 points. So the first point is generally taken as, here it is, let us suppose x1 y1, and it is x2 y1. Why? Because here the line is parallel to the x-axis. So since the y-ordinates are equal, points lie on a line which is parallel to the x-axis. So here let us consider P and Q. So here the distance between P and Q is obviously modulus of x2 minus x1. Okay, so here by observing the figure, APBQ is a rectangle. Therefore, we have here AB is equal to PQ. So in this way, we can find out the distance between the 2 points on a line which is parallel to x-axis. So distance between 2 points on a line parallel to the x-axis. So in similar way, we have to find the distance between 2 points on a line parallel to y-axis. In that way also we can find easily y2 minus y1. Okay, now here like this we have to find the distances between any 2 points in a coordinate plane, or it is also called as a Cartesian plane. Already we will know that one. And next, the distance between the 2 points on a coordinate axis. For example, I am taking, this is x-axis, y-axis, and this one is y. That is why I am taking the first quadrant. In this I am taking 2 points. One is 0, 4 on y-axis and 0, 4, 0 on x-axis. Okay, or 3, 0 on axis. So let us suppose that it is A and this one is B. So I would like to find out the distance between these two. Okay, now here actually by observing the figure, it is a right angular triangle. So from O to A we have 3 units, O to B we have here 4 units. So by applying the triangle AOB is a right angled triangle. So we can apply Pythagoras theorem. That is, we can write AB square is equal to OA square plus OB square. So simply we can write it as 3 square plus 4 square, 9 plus 16, 25. So then AB is equal to, we can write root 25, simply 5 units. So like this we can get easily the distance between the points on coordinate axis. Okay, now let us see next. Now students, distance between any 2 points in the xy plane. Here I am taking xy plane, and this one is horizontal line x dash ox and vertical line. So I am taking any 2 points A x1 y1 and B x2 y2. Okay, so now the distance between these 2 points can be found out by geometrically like this. Here we can draw a perpendicular line from A to on x-axis, let it be P, and again draw one more line from B to let it be Q. Now again draw a perpendicular line from A to BQ, let it be R. Now the distance between this B and R generally taken as y2 minus y1, as already we know the distance between the B and R is simply we can write y2 minus y1, and the distance between the P and the Q generally it is till here x1 units, and from here to here x2 units, that is x2 minus x1. Like this here also, from Q to B y2 units and A to P or B to R y1 units. So the difference between BQ and QR is simply y2 minus y1. So now by this way we can find the distance between the AB. So once again we will write here. Let us assume A x1 y1, B x2 y2 be any 2 points in a plane or on a line. Okay, now draw AP and BQ perpendiculars to x-axis. Now draw perpendicular AR from A on BQ. Already we draw that one. So then, as we know, OP is equal to x1, OQ is equal to x2, then PQ is simply OQ minus OP, OQ minus OP, that is simply x2 minus x1. So in this also on BR, that is BR is equal to, we can write simply BQ minus QR, that is y2 minus y1. So in triangle A or B, we can get AR is equal to, that is PQ is equal to x2 minus x1, and BR is equal to simply y2 minus y1. Now actually at R we have 90 degrees. So by applying Pythagoras theorem we can write AB square is equal to, simply we can write AR square plus BR square. So the distance between A and B is AB square. That only the square of the two distances, and the 2 points AB square is equal to AR square plus BR square. Then we can write here AR square is, here we have x2 minus x1, x2 minus x1 whole square plus br square is y2 minus y1 whole square. So we need here only AB, the distance between A and B. So by taking square on right side we get square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so they may be asked to obtain the formula of the distance between 2 points in a plane and xy plane. So they will ask like this, like that we can do in this way. Okay, very easiest by applying Pythagoras theorem. Okay, so in this way we have to obtain the distance between the 2 points on a given plane. Now let us see one example. So the distance between the 4,3 and 8,6. For example, find distance between A 4,3 and B 8,6. Now compare these points in solution. So compare these values by x1 y1. Here x1 y1 is taken as 4,3. So x1 is 4, y1 is 3. And compare other point by x2 y2. So x2 is 8, y2 is 6. So by formula we can write the distance formula AB is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. So by applying x2 minus x1, 8 minus 4 whole square plus 6 minus 3 whole square. So 8 minus 4 whole square is 4 square, 6 minus 3 whole square is 3 square. So under root of 16 plus 9, simply we get root 25, that is equal to 5. So like this we can get the distance between A and B. So next concept, collinearity. So collinearity means if 2 or 3 points are lies on a same line, we can say that 3 points are collinear. Okay. Now, so on that one we have one sum here. If A 3, 1, A is equal to 3, 1, B is equal to 6, 4, C is equal to 8, 6. So then verify ABC are collinear or not. Okay, now let us find again here distances. Say AB distance. So AB distance, we have the formula under root of x2 minus x1 whole square plus y2 minus y1 whole square. Just compare those points by x1 y1. So x1 is 3, y1 is 1, and x2 is 3, y2 is 6, y2 is 4. By substitution we get AB equal to under root of 6 minus 3 whole square plus 4 minus 1 whole square. That is 3 square plus 3 square. Simply we get 9 plus 9. That is root 18. Root 18 nothing but square root of 9 into 2, that is 3 root 2. In the same way, find BC. So by applying the same formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square, x1 6, y1 4, x2 8, y2 6. BC equal to under root of 8 minus 6 whole square plus 6 minus 4 whole square, that is 2 square plus 2 square, simply we can write it as 4 plus 4, that is root 8, that equal to 2 root 2. Now again here CA under root of x2 minus x1 whole square plus y2 minus y1 whole square. So here x1 is 3, y1 is 1, x2 is 8 and y2 is 6. So then CA is equal to square root of 8 minus 3 whole square plus 6 minus 1 whole square, then 5 square plus 5 square under root, so under root of 25 plus 25, that is root 50, so we can make it as 5 root 2. Now observing all the distances, we have here AB equal to 3 root 2, BC equal to 2 root 2 and CA is equal to 5 root 2. That means by addition of AB plus BC, that is 3 root 2 plus 2 root 2, we get 5 root 2, which is equal to CA. Hence we can say A, B, C are collinear because they are lies on a same line. Hence A, B, C are collinear. Okay, so like this we can do collinearity. So we can apply that rapid triangle formula also, but in this case we can practice this distance formula. Okay, so to practice distance formula, do in this way also. Okay, thank you. Now let us see section formula. Section formula means if a point divides a line joining of AB in the ratio of m is to n, then the coordinates of the point P gives us by this section formula. So now let us consider any 2 points, any 2 points A and B on a plane x1 y1 and B x2 y2. So let us consider these 2 points on a plane. And P divides AB internally in the ratio m1 is to m2. Then here we have one diagram. Say this, I am taking one plane. In first quadrant, now here let us take 2 points A, x1 y1 and B, x2 y2. Now the line joining of these 2 points is divided by a point P in the ratio of m is to n. So now let us draw the perpendiculars from A to x-axis and P to x-axis and P2 that x-axis. Let us consider those are AR, PS and PT. Now again draw the perpendiculars from A to PS and P to PT, P to BT. So, and here we can take AQ and PC. So after that we have to write the measurements. Already we have here AP by PB is M by N. AP by PB is equal to M by N. And here anyhow from here to here OR is X1 and this AR is Y1. And again O to S is X, then R to S is X minus X1, that means, and this is also X minus X1. And again here SQ also Y1 and here P2S is again Y total, then PQ is simply we can write Y minus Y1. And next here again O2T is X2 and O2S is X1, so that's why here it is X2 minus X1. So PC is X2 minus X1 and here full BT is Y2 and BC is X, so here Y, so that's why here we can write C2Y is up to Y and this one is Y2, so totally the difference between the B and C, there will be the distance between the BC is Y2 minus Y. So let us see all the measurements. Here we have AQ is equal to RS is equal to OS minus OR. AQ is equal to OS minus OR, that is simply we get X minus X1. OS is X, OR is X1. And again PC, and here also we get PS minus QS, that is PS minus AR, that equal to, this is actually PQ, PS minus QS is equal to PS minus AR, that is Y minus Y1. And PC is equal to ST, that is OT minus OS, simply X2 minus X, X2 minus X. And next BC is equal to BT minus CT, that is BT minus PS, Y2 minus Y. That means we have to find the measurements of this triangle APQ and BPC. Why? Because by AQ and PC are parallel to the x-axis, so then by angle similarity criterion we can say angle PAQ is similar to the triangle BPC. Triangle PAQ is similar to the triangle BPC. So after finding out these measurements, we have to compare that corresponding ratio of the sides, ratio of the corresponding sides. So here first of all write AP by PB is equal to AQ by PC is equal to PQ by BC. So then we can get here M by N AQ is x minus x1, PC is x2 minus x is equal to PQ y minus y1 by BC y2 minus y. So we have here three equalities. So first take from these two first equality. From first equality we can write m by n is equal to x minus x1 by x2 minus x. Then on cross multiplication we get m into x2 minus x is equal to n into x minus x1. So mx2 minus mx is equal to nx minus nx1. So our aim is to find out x coordinates. So that's why x is one side and x1 x2 is one side. Take this and x1 to this side, mx to this side. So we get here like this: mx2 plus nx1 is equal to m plus n into x. Therefore x is equal to mx2 plus nx1 by m plus n. In the next we have other relation, m by n is equal to y minus y1 by y2 minus y. On cross multiplication we get m into y2 minus y is equal to n into y minus y1. So my2 minus my is equal to ny minus ny1. So take that my2 plus ny1 is equal to ny plus my. So we get here my2 plus ny1 is equal to m plus n into y by taking common y. Therefore y is equal to my2 plus ny1 by m plus n. So the coordinates of P x comma y, mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. That means the coordinates of point P x comma y, which divides the line segment joining the points ax1 y1 and bx2 y2 internally in the ratio m1 is to m2, or mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. Okay, or otherwise we can take m1 is to m2 also. If you take m1 is to m2, so the formula will be like this: P is equal to m1x2 plus m2x1 by m1 plus m2 and m1y2 plus m2y1 by m1 plus m2. Like this also we can write the formula.